you see a graph like this and you're asked to find out what element it is, you can just start by looking at the x-axis. So you can see that it's labeled 1, 2, 3, 4, 5, 6, 7, and then 8. So this is like the number of electrons that have been ionized. I mean, that have been kicked out of the atom's forces of attraction. So when you go to the periodic table, you know the one with 8 electrons is oxygen. So then you can safely say that this is oxygen, because this is the amount of energy required to ionize oxygen completely. When you are ionizing something in a gaseous phase, the outermost electrons are going to go first. So when you start ionizing it, your first electron, the valence shell electrons, which is so it's the electronic configuration is 2.6, right? So it starts from here. So when it loses this, it becomes 2.5. Then when you lose this, it becomes 2.4. Then 2.3. Then 2.2. Then 2.1. And then it's just back to the first 2 electrons, which are closest to the nucleus. So this huge steep incline is basically to show the different energy levels. The 2 and then the 8, or in this case, since it has 6 electrons, it's 6. So 2.6. The reason that the energy, there's not such a great space between between the electrons from the 6th part, which is these, is because they're all located in the valence shell of oxygen. So in the valence shell, they're further away from the nucleus, and they have less attractive forces from the protons in the nucleus. And here the shielding is also going to be constant, because it's always going to be the 2 electrons from the core of oxygen. So if we had to draw it out, oxygen would be, this is oxygen. This is your first shell. You'd have 1, and you'd have 2. Then you'd have this one, which is 1, 2, 3, 4. So what's happening here is these first 6, 1, 2, 3, 4, 5, 6 are being taken out during the ionization process. And now you can see just by my diagram, it's visually a lot further from the nucleus, which contains positive charges. This means that the force of attraction here is a lot weaker than it is here. So if it's stronger, it's going to require more energy to help set the electrons free from the attractive forces of the protons. So using that knowledge, you can tell that after these 6 are gone, it's going to look something like this. And you're going to have, it's going to look something like this. And you're going to have O6 plus, I think. Yeah, you're going to have an O6 plus. Now, we're over here, where it's much closer to the nucleus. Hence, the energy required to take out one of them causes such a steep incline.
Okay.
And finally, take out the last one to make sure the atom has no electrons. Takes lesser amount of energy because there's not a big difference between because the electrons are the same distance from the nucleus. So the energy increase isn't the same as it is here.